Hello and welcome to today's class. Let's solve this a simple exponential challenge together. All right, so the question is 4 to the power of x plus 4 to the power of x equal to 49. What is the possible value of x that will satisfy this challenge? Solution. All right, so if you look at this, these are the same. And so all we just need to do is to add the two of them together. So adding the two of them together means we are bringing out 4 to the power of x. If we factor that out, this will give us here 1, and this other side 1, and we have this to be 49. Then adding this is going to give us 2 times our 4 to the power of x. Better still, let's put it in a bracket equal to 49. Now from here, we divide by 2. Okay, so if we are dividing this by 2, we divide this side by 2 also. So let's divide this by 2, we divide this by 2. So this leaves. We are now left with our 4 to the power of x equal to our 49 all over 2. Now we know 49 cannot, 2 cannot go into 49 rather. Okay, so what we do, but we know this is a perfect square. So 7 to the power of 2 will give us 49. So let's go ahead and rewrite this. So we're going to have 4 to the power of x is equal to 7 to the power of 2 all over 2. Wow. Now, I want to bring out 7 under this place here. Although at this point, we can take log to base 10 on both sides or ln both sides of the equation. But here, let's have some fun solving this using another approach. So I want to rewrite this. 2 can be written as our 14 all over 7, right? Yes. So 14 all over 7 will give us 2. So I want to introduce that to this side. So we're going to have here 4 to the power of x is equals to our 7 to the power of 2 all over 14 all over our 7. Okay, so let's see what this gives us. Then from here, if we divide this by this is going to give us our 4 to the power of x is equals to 7 to the power of 2, right? All over 1. Then dividing our 14 all over 7, which is automatically going to have 7 to the power of 2 all over 1 times our 7 all over 14. From what we have here, it is pretty easy. We can either rewrite this 14 or we leave it in this format. Okay, 14 is the same thing as our 2 times 7. So if we go ahead to rewrite it, this is going to give us 7 to the power of 2 all over 1 times our 7 all over 2 times 7. Easy. So I want to bring out these 2 from the system here. So this is going to give us here 1 all over 2 into our 7 to the power of 2, then times our 7 all over 7. Easy. So writing the whole of this expression is going to give us 4 to the power of x is equal to 1 all over 2, then times our 7 to the power of 2 all over 1 times 7 all over our 7. The next we're going to do here is to log both sides of the equation. So, but before we log both sides of the equation, we can express 4 in base 2. So 4 can be written as 2 to the power of 2 times this x, 2x here. There this is equals to 1 all over 2, there times our 7 to the power of 2 all over 1 times our 7 all over 7. Now, if you check this now, you discover that we're having this 2 here, we're equally having 2 here. So we want to log both sides of the equation. But we're going to consider a log to base 2, not to base 10 here. So if we take log to base 2, so we're going to have here log 2 to the power of 2x base 2, then equal to the log of base 2 into our 1 all over 2 times 7 to the power of 2 times 7 all over 7. I know 7 all over 7 will give us 1, right? Good. But let's still go on. The reason why I decided not to divide this down is because this will now take us back to this side. And I told you we could as well simplify this down, but we just want to have some fun here. All right, so what we do next here now is this. We apply the power law of logarithm, which says that if you have your log x to the power of k, move this k back to give us here k times log our x, right? So if we apply that power law, we're going to have this to be 2x, right? That times our log 2 base 2 is equal to, then here we're going to apply what is called the additional law of logarithm, sorry, multiplication law of logarithm, which is your, if you have your log m times n, say this is equals to log m, then plus log n. So if we apply this to this, then we're going to have this to be our log 1 all over 2 base 2, then plus log 7 to the power of 2 base 2, plus log 7 base 2. All right. So you now discover here we are having log 2 base 2. Then we can rewrite this. Then see what this gives us. Applying the power law of logarithm. So we can rewrite this as, let's go ahead and rewrite this. Log 2 base 2 will give us 1. According to the law, we say that if you have your log a base a equal to 1, provided a is not equal to 0. So this will give us 1, right? And we can rewrite this by moving this backward, but let's take this first. So this is going to give us 2x is equal to, rewriting this according to the law of indices, this will give us log 2 to the power of minus 1 base 2, then plus, here we still have this here, log 7 base 2 plus log to the power of 2, right? Okay, to the power of 2, then log 7 base 2. Okay, so we move this back, according to the law. So this is going to give us our 2x is equals to minus 1 times log 2 base 2 there plus 2 times log our 7 base 2 there plus our log 7 base 2. Easy. All right. So here we have log 2 base 2 again. That will give us 1. And here we're having 2 log 7 base 2. Here we have just a visible 1 log 7 base 2. So we can add these two. So this is going to give us our 2x is equal to minus 1 then plus, look at this here now, right? So this is going to give us 3 log 7 base 2. Easy. So rewriting this is going to give us 2x is equals to 3 into our log 7 base 2 minus 1. We divide by our 2 because we are looking for earth. So we divide by 2, we divide everything here by 2. Cancel, cancel. So we have our x will now be equal to, we have our 1 all over 2 into, okay, let's put this down first. So we have here 3 log 7 base 2, then minus our 1 close bracket. So we have to change this to base 10. Okay, so we apply the change of this law. We say that if you have your log, your a base b, changing this to base c, this is going to give us our log a base c all over log your b base c. So if we apply that here, this is going to give us 1 all over 2 into our 3 into log 7, then base 10 all over log 2 base 10, then minus 1 close bracket. Okay, so therefore our x is equal to our 1 all over 2 into, we have here 3 log our 7 base 10, then minus log 2, okay, log 2, then base 10 all over our log 2 base 10. So this is our final answer. All right, so it's a simple one, but I just decided to take the long way or the lengthy way. Thank you.